Okay, good morning, folks. So this week we're going to continue with hypothesis testing as section 8.2. The earlier sections we kind of went over and discussed what the process of doing a hypothesis test. And we're going to continue that. In this next video, I'm not going to go through all the steps. I'm only going to go over how to find what's called the test statistics. So if you go back in your notes and you look at this slide right here, slide number 7, we're going to focus on generating this test statistic in this video. I don't want you to go into another video until you can do these. And on your homework, if you look at the 8.2 homework, I would like y'all to do numbers 13 through 16, all of them on page 411. All you're doing there is what I just said. You're finding the test statistic. So please go ahead and make sure you do that. Now, there are 3 kinds of test statistics there that we'll be focusing on in this class. There is the proportion, the mean with a T, and the mean with a Z. So we're going to go over each of those. Also, when I read a problem today, I'm going to go over the hypothesis test. The coming up with a null and alternative, and then we are going to determine what kind of test it is, and then do the test statistics. So that's today's goals. That's the objective for today. All right. So back to hypothesis testing. So here in example 1, it says in Pennsylvania the average IQ score is 101.5. The variable is normally distributed, and the population standard deviation is 15. A school superintendent claims that her students in her school district have an IQ score higher than the average of 101.5. She randomly selects a sample of 30 students and finds the mean test scores to be 106.4. Test the claim at an alpha of 0.05. Okay, so first thing I notice is that population standard deviation, normally distributed. Let's see here. And our sample size is 30. So we are using a z-test because my sample size is appropriate. I know the population standard deviation. That's a key portion of this. So what I'm going to do is I have a Google sheet that I'm going to pull over. Give me a second. Alright, here is my Google sheet. So the claim, here, I wrote down greater than. So my null hypothesis would be, so my null hypothesis would be that there is no difference. So we're saying mu is equal to 101.5. Alternatively, we're saying mu is greater than 101.5, because we're saying her population, her classes, is higher than the average. So you notice right here in my claim, I just put a greater than symbol. My level of significance, let's go back to that. My level of significance, let me see if I can't do this. Here we go. My level of significance is alpha is 0.05. So easily just type that in right there. Boom, 0.05. What does her sample mean? Well, what did it from her sample of 30 students? What did she get? She got 106.4 as her average. Population mean, we said it was 101.5. Standard deviation, we know is 50. Notice right here, population standard deviation. Sample size is 30 students. And I went ahead and have these formulas written out already. Standard error, that is, let's go back to the notes. Let's go back to our formulas. So since we're doing a z, here's a z, this bottom part of the denominator right here, standard deviation divided by the square root of the sample size, that is our standard error. So back to here. All I did is, you'll see the formula I have written here off to the right, is I did B6, which is square root of the population standard deviation divided by the square root of our sample size, which is 30. Okay? That's standard error. Now our test statistic, what you do to find your test statistic is you do, let's go back to our formula, do the sample mean minus the population mean divided by standard error. And you'll notice that's what I did. B4 is the sample mean, B minus B5 is the population mean, all divided by our standard error, which we just got in the last one. So if you click here, you'll notice I have that right there, B4 minus B5 equals B8. And that's all I want you to do today. That's it. So now on a calculator, it's very straightforward. You're just literally typing in what it says. I would recommend you push alpha y equals enter to get that beautiful fraction bar. So 106.4 minus 101.5 divided by our standard deviation, which is 15, divided by the square root of our sample size, which is 30. And there it is. That's our test statistic. We should be getting the same exact value on both sheets, which we do. We got the same exact value. All right. Now, for your homework, for those who are using Google Sheets, you can just use this formula, just change numbers, and it'll automatically change the test statistic for you, so it shouldn't be that much of an issue. So now let's go ahead and go on to the next example really quickly here. All right, so now let's see here, example 2. By the way, I have not answered the question. I'm stopping at the critical value and the conclusion. We have not discussed that, and we will not discuss that today. Okay, so for this one, for a specific year, the average score on the SAT was 515. The variable is normally distributed, and the population standard deviation is 100. Population standard deviation is the same. Superintendent wishes to see if her students get significantly below the national average on the test. She randomly selects 36 of them with an average of 500. Okay, so what I'm going to do, I'm going to take this, because it's essentially the same exact stuff, same formula, so I don't want to rewrite it, at least for the test statistic portion of it.